What would you say if we told you that the pain you feel is really just in your head? Would the world be a better place if we could all control our own pain experience? But first, what is pain? Pain is something common to us all. It's undesirable and uncomfortable, and as humans, we have the natural tendency to avoid it. Today we have the means to soothe such pain. But what if we could avoid this discomfort just with our own mind? Before we can control pain ourselves, we must first explore how we detect it. There are two particular areas of the brain that lights up when pain is felt. The first is the nucleus accumbens, which regulates pain by receiving dopamine. This structure connects to the ventromedial prefrontal cortex via the fronto-striatal neural circuit, and it changes our behavior to avoid pain. Researchers at the Cognitive and Affective Neuroscience Lab, led by Professor Tor Wager of the University of Colorado, have found that there are two distinct pathways that construct our conscious experience of pain. One pathway involves a primary nociceptive system, which activates when actual noxious stimuli is applied. This is represented as the neurological pain signature, which is a distinct pattern of activity in the brain which represents physical pain. The other neural pathway, the fronto-striatal neural circuit, is completely independent of the stimuli. Now, Wager's study tested 33 participants which were exposed to thermal stimuli of varying intensities in their left forearm. They were then asked to report their experience of pain, while at the same time their brain activity was monitored using functional MRI.
The neurological pain signature activity mirrored an increase in the temperature of stimuli in conjunction to the participants' own report of the pain felt. As such, there was no change in the activity of the neurological pain signature when participants self-regulated their pain experience through the guided thought processing. With respect to the other pathway, the nucleus accumbens was unresponsive to the increasing stimulus intensity and was highly active during the cognitive downregulation. Thus, this suggested that the Fronto-Striatal Pathway contributes strongly to the mediation of perceived pain. It is evident then that the noxious pain and cognitive self-regulation of its perception are in fact controlled by two separate brain systems. The neurological pain signature responds solely to the changing intensities of the noxious stimuli, whilst the Fronto-Striatal pathway mediates our perception of it. These findings have effectively laid a foundation for the future research into pain perception, whether it be nociceptive, evaluative, or sensory. Ultimately, the study was successful in addressing the nature of self-regulation and its involvement in the pain response. This aids our understanding of the complex and multidimensional nature of the various sensory pathways and perception. By exposing the pathways sensitive to the cognitive self-regulation, it's possible to explore applications for other sensory modalities and improve them. This opens possibilities into the characterization of healthy individuals compared to dysregulated patients in terms of multiple pain-related systems. Hence, this would allow the integration of this research to future diagnosis and treatment, namely the evaluation of the current self-regulation strategies employed and the circumstances to which they can be applied. From this, the treatment of pain can then be directed at the primary affective response or by altering the evaluated component. It's undeniable that we will all experience pain at some point in our lives, but if we can control our perception of pain, then perhaps suffering can be a thing of the past.